Hello everybody, today we will be working on the exam review 2 for Math 1813. So starting with the first problem, it's going over section 2.3 transformations. It says a transformation takes the function f and creates a new function given by the formulas in column 1. Assume the point 12 minus 6 lies on the graph of f. Match the formula 1 to a correct interpretation, 2 in the coordinates of a point on a new graph. So as we see, we have this point 12 minus 6, which is the same as x f of x, right? And this right here will help us to be able to interpret what's happening in these here and be able to find the coordinates of the new point. So first of all, the first one is g of x is f of 3 of x. So if the transformation is happening on the inside of the parentheses or if it's happening directly to the x, then we know this is going to be a horizontal change of some sort, whether that's a horizontal shift or horizontal compression or stretch. In this case, we have 3x, which means it's a horizontal compression. And the way compressions work is you will have, so essentially this is a horizontal compression, right? And it's a horizontal compression of a factor of 1/3. And the reason for that is because when you compress horizontally, you're going to need smaller x values so to make your graph make sense. So for this one, it'll be g, so I'll write that up here. And then our coordinates will be something like, so we said 12 minus 6, and we are taking it by a factor of 1/3 of our x, and our f of x is not changing. So that'll look something like this. 1/3 of our 12, which is 4, and our f of x stays the same. So be 4, negative 6. Next one says h of x is 3 f of x. So as you see, this 3 is on the outside of the entire function. So this is actually happening to the entire thing, or more so to the f of x. And this means, because it's greater than 1, it means it's a vertical stretch. And this vertical stretch is by a factor of 3, because as we're stretching up, we want larger values, so we want to multiply our f of x values, or our y values in this case, by 3. So we know it's a vertical stretch by a factor of 3, so it's not this one right here. This one says it's by a factor of 1/3, and that is not true. But so what that means is we actually are multiplying all the y coordinates by 3, which is the same as saying vertical stretch by a factor of 3. So we know that is b right there. And then our new point, so our original point was 12, negative 6. Our new point will just be our x stays the same, 3 times f of x. And that would be 12, negative 18. So I'm going to go ahead and erase this so we can work on the rest of them. So the next one says I of x equals to f of x minus 3. So as you can see, that negative 3 is happening to that x and that x alone. So we know this is going to be a horizontal change of some sort, or a change to the x values. So if we know the rules, if it's minus 3 on the inside, so if it's x minus h, like that, we know that this is a horizontal shift. Right? So if we have f of x minus 3, we know that this shift is happening to the right. Right? So we know that we are shifting our x values 3 to the right. So that is this f right here, shift right 3 units. And if we think about it as far as our points, if we have the point that, we need to change it to, if we're shifting, we need to change it to x plus 3, right? Because we're shifting it to the right 3. And then our f of x stays the same because we're not changing anything to our f of x. So that will look something like 15 negative 6. So that would be right here, 15 negative 6. I'll go ahead and erase this. Okay. So now, the next one says j of x is f of x minus 3. If you see this minus 3 is happening to all of f of x, so that means that it's happening to the y coordinates in a sense. So what this means is that from our point x, f of x, our new point will be moved down by 3 units. Shifted down by 3 units, because this is one of those f of x plus k, and this is a vertical shift. And this, unlike the h that we talked about earlier, takes on the sign that it has because of that plus, but that h earlier had a minus in front of it, so you take the opposite of it. So this one's shifted down by 3 units, so it means our point will look something like 12 stays the same, and this one would be minus 9. Oh, and then to find it down here, we are adding or shifting down 3 units, right? Okay, and then I'm going to go ahead and erase all of this again. All right, this next one says k of x equals f of x plus 3. So just like this one up here, we know this is a horizontal shift, and because we said that this is happening, we actually know it's f of x minus a negative 3, like that. So we know we are moving minus 3 units. So that means we are shifting 3 units left. So if we look here, that means we're going to subtract x coordinates by 3, and that will make our point look like 12 minus 3, which would be 9, and our f of x stays the same. All right, last one says L of x equals f of x plus 3. So just like this one, this is happening to the entire function, therefore it's happening to the y coordinates, or it's happening along the y-axis. So like we mentioned earlier, f of x plus k, this is just f of x plus 3, which means, so this is vertical shift. This means it's just being shifted 3 units in the vertical direction, in the positive vertical direction, which is up. So then that means we're going to be adding 3 to the y coordinates, and our x stays the same, and if we add 3 to our negative 6, we get negative 3. Alrighty, so now on to the next problem. Number 2 says a function g is a transformation of f of x equals square root of x, given by g of x equals 3, f of negative x minus 2, minus 1. Write the formula for g of x in terms of the square root function. So what this is saying is if we know f of x is this square root of x, we are trying to find out what g of x is, given that g of x is 3 times f of negative x minus 2 minus 1. So if we look at this, the x is under the radical. So anything that happens to the x only has to also be under the radical, and anything that happens to the entire function has to be outside the radical. So what's in here is happening only to x. So when we write it in our under our radical, we know that's going to be negative minus 2. Okay, and then as we see, everything else, so everything here and here, happens outside the f of x, so it happens to the entire function, so it'll happen outside the radical. So that means this entire thing will get multiplied by 3 and will be shifted down by 1 unit. You can also write this by factoring out a -1 under the radical. And you could get something like x plus 2. And if you were to distribute this through, it'd be the same thing. And then -1. So these two are equal, but you can answer with this. All right, on to problem 3. It says a function f has a domain -20 to 15, range -1 to 12, and a point -5 to 7 lies on its graph. The function h is a transformation of f given by h of x is 3 f of 5 of x plus 6 plus 2. Describe the transformations in any correct order. So this is what we are trying to describe. So as I've stated previously, anything that happens inside the parentheses happens to the x values or happens horizontally. And then everything that happens outside, so like this here and this here, are happening to the entire function or their vertical transformations. So you can actually do either the horizontal transformations or the vertical transformations first because they happen independently of each other. I always like to start with the horizontal first. So you will go ahead and state. So horizontal first. So we'll talk about what the horizontal transformations are. Looks like you are multiplying things by this 5, right? Which means that you are compressing by a factor of the reciprocal of that. So you are actually compressing horizontally by a factor of, and I said the reciprocal, 1 over 5. And then another thing that's happening here is this horizontal shift. And we know, like I mentioned earlier, it's usually x minus h, so it's the opposite of what's showing there. So it is actually a horizontal shift left 6 units. So you are shifting horizontally left. Right? Okay, now we'll talk about what's happening vertically. So vertically, we have this here. Actually, I'm going to make that a different color. Vertically, we have this here and this here, correct? So this 3 is kind of like that 5. It's similar. But this time, it's actually stretching by a factor of 3, not the reciprocal. So it's stretching by a factor of 3, and this is a vertical. And then we see here that this 2 is happening to the entire function, and that means that our entire function is being shifted up 2 units. So it's a vertical shift or up 2 units. All right, now it says here, what are the domain and range of h? So our new function, what you can actually do to check your domain and range is you can actually take the original domain and range. So let me do the original domain and range. So of f of x was -20, 15. And the range was -1, 12. So if we take what we know here as far as the shifts, then we can do each of these. Find the new domain and range. So the new domain and range, they have the same endpoint behavior. So it's including the left endpoint and it'll exclude the right endpoint. So this first one, I'll do the domain in red because it's what's, domain is the x, right? So it's what's horizontally, the horizontal transformations will affect the domain and the vertical transformations will affect the range. So the domain we know it's compressing horizontally by a factor of 1/5. So we're going to take 1/5 of what we originally know, and then there's a horizontal shift left 6 units, so we're subtracting 6. So that should be our new value for that, and then we'll do the same thing for the 15. So 1/5 of that 15 minus that 6. And all of that, and that right endpoint, like we said, is excluded, so we have a parenthesis around it. Now, similarly here, we are taking a vertical stretch by a factor of 3. And then we are shifting up 2 units. And then similarly to the 12, by a factor of 3, oh, that's a positive 12, and we are shifting up 2 units. And again, that left endpoint's excluded. So, with all that being said, our new domain looks something like -10, -3, right? Because that's right here, that's -4, minus 6 is -10, and this is 3 minus 6, and then this here is -3 plus 2, which would be a -1, and this is 36 plus 2, which would be a 38. All right, now it says, name one point that must lie on the graph of H. So, from what we can do is similar to the domain range. We know a point on f of x. We know this point, -5, 7. And we want to find a new point. So what we can do is we can transform each of the coordinates, or each the x and the y, into a new point that will lie on graph H. So similar to what we did up here, because x is what's happening horizontally, we'll take 1/5 of our original x, and then we'll shift left, and then we will take a vertical stretch by a factor of 3 of our original y, and we're shifting up 2 units. So our point on h of x should be, this is a -1 minus 6, -7, and this is a 21 plus 2, 23. So this is our new point. And I'll write that right here. Oh. So our new point is -7 to 23.
Okay, so for this next one, it says find a formula for the function g as a transformation of the function f. So I look at this function f, we have this first point, which is 8, 1, and 0, 1. And we do our transformation to it, and it becomes 0, 4, and 4, 4. So the question is, what is the transformations, and can we write that out like with an equation? So the first thing I see is that this gets way taller, right? Like this goes from 0, 1 to 0, 4, and this like bottom part drops really far down to there, right? So that means I'm stretching it vertically. So I know I'm gonna have a vertical stretch. So I'll just kind of put a little note, a vertical stretch, if it will let me write. Vertical stretch. It's really bad handwriting, I'm sorry about that. And then what else are we gonna have? Well, it's also getting really skinny, right? Like this left side is staying also at like x equals 0, but the right side is getting half as small. So that means that we're gonna have a horizontal compression as well. So when I think about how to figure these out, right, I'm going to first kind of think about like where do these transformations come from. So vertical stretch, so if I have my g of x is some set of transformations from my f of x, right? What this is going to look like is going to be some a value for my vertical stretch times f of b of x. B is going to be the horizontal compression vertical stuff always are on the outside of this F thing. So a vertical stretch can be on the outside and it's going to act pretty normal, right? So for in this case, my y value is from 1 to 4 and 1 to 4. This value goes from 1 to 4. This value goes from 1 to 4 in terms of y values. What am I doing, Champ? Well, I'm multiplying them all by 4. So that means my a value is going to be 4. Stuff on the outside is going to act pretty much as we expect it to. So it's going to be 4 times. Now for this b value, that's going to be the inside stuff. That's going to be horizontal. Well, horizontal stuff kind of acts opposite what we think, right? If you see, for example, I got a square root of, I'm highlighting now, square root of like x plus 2. Instead of saying, oh, that's going to, we're adding, so it's going to shift it right 2, no, you actually go to the left 2. So the inside stuff kind of acts opposite. So instead of multiplying by this b value, I'm going to multiply my x coordinates by 1 over b. Or, if my x coordinate is 8, I'm going to multiply it by, not by b, not by the amount I'm by 1 over, by 1 over b. Because I'm compressing it, vertical stuff kind of acts opposite. And I'm going to end up with a new x value of 4. So I go from this point to this point, I go from 8 to 4, and I'm going to be multiplying it by a compression factor of 1 over b, where b is going to end up being the number in there. So that means that 8 is going to equal, multiply both sides by b, 4b, and that 2 will then equal b. So that means for my equation, g of x is going to equal 4 times f of 2x. And again, to just rephrase, this multiplied by 4 on the outside stuff goes to vertical transformations. So we multiplied our y values times 4, so it goes from 1 to 4 and 1 to 4. And then the inside stuff kind of acts opposite what you think. So you see this times 2 is actually divided by 2. So this x value of 8 divided by 2 becomes 4. This x value of 0 divided by 2 is still 0, because 0 divided by anything is 0. Okay, so now for number 5. Write a formula that takes a function f and transforms it as follows, in order. So the first thing is going to be reflect across the x-axis. The second is horizontally compressed by a factor of 1/3. After that, it's going to be shift right 4 and then shift up 5. So I'm going to first say that we have this f of x. And we're going to go through our transformations on this f of x one by one. So the first one we have is reflect across the x-axis. So if I think about my number line, reflecting across the x is going from there to there, or vice versa. Right? You're going from up there down to there, because the x-axis is this middle line. So that means I'm reflecting it vertically. Vertical stuff always happens on the outside. So that means if I start off with f of x, to reflect it vertically, I'm going to put a negative on the outside. So that's just the first transformation there. Okay, now that I have negative f of x, let's go through the next one. Horizontally compressed by a factor of 1/3. Well, as I discussed earlier, horizontal stuff kind of acts a little bit opposite what you expect. So when you're compressing by a factor of 1/3, what you really put in there, inside the function, is you flip this fraction. So 1/3, if you flip it, I kind of point the arrows, you get 3 over 1. You're saying it has 3. So inside, because horizontal stuff happens on the inside of our f of x, we're going to have a 3x. Right? We're still having the negative in front because we're reflecting it first, but now we're also compressing it horizontally by a factor of 1/3, so we're multiplying the inside by 3. Next up, we're going to shift it right 4 units. Again, this is left-right stuff, horizontal, that's inside. Inside stuff kind of acts opposite, so instead of adding 4, we're going to subtract 4. So we'll have to do a minus 4. So I'll take the x thing, and I'm going to keep the 3 outside. That's really important that we do that. And I'll put a minus 4 in with the x. That minus 4 is going to shift it right 4, because inside stuff kind of acts opposite of what you think, the same way that this times 3 is really going to multiply times 1 over 3. Finally, shift up 5. Well, up is on the outside. So we're going to add on the outside of the F thing, 5. And because it's vertical, it acts as we expect. So we add the 5 out there. So now for this next one, we determine whether it's even, odd, or neither. So it's going to be even whenever if we plug in a negative x for f. So we'll say it's going to be even when f of negative x is the same thing as just leaving as f of x. That's even. It's odd is if f of negative x is the same thing as just making the whole thing negative or switching the sign on everything. And if it doesn't hit either of those, it's going to be neither. So let's go and plug in negative x, and we'll see if does it stay the same? Is it the same thing as making the whole thing negative, or is it something different? So f of negative x is going to be the square root of negative x squared plus 1. Well, negative x squared, negative x times negative x, well, the negatives cancel. So we just get positive x squared. And that's the exact same thing we had before, so we say that is even. So now the question is, an even function f is decreasing and concave down in the first quadrant. What can you see about the function's behavior in the second quadrant? So first, I'm going to think about my quadrants. Got to think about like, okay, what does it mean by quadrants? It won't let me see if it, okay, sorry. Okay, so the first quadrant is the one we're used to. And this goes around counterclockwise. So it goes second, it's the other one on top, third, and the bottom one it is fourth. So if I know it's decreasing and concave down in the first quadrant, so it's decreasing and concave down means it's decreasing faster and faster and faster. What can be said about it in the second quadrant? Well, it's even. That's the big thing. Even stuff means that they're symmetric across your y-axis. In other words, if you know one side of it, the other side is going to be the exact same thing, but it's going to be reflected. So now, what can we say about it on the other half? Because it's just reflected from the first half. Well, now, as we go, it's going to be increasing. So it is increasing. In terms of concavity, right, it's increasing, but it's going to be less and less and less. So we're going to say that's still concave down. Okay, so for this one, so this is a section about linear functions. So the first one is a bathtub was partially filled with hot water when the cold water tap was opened. 2 minutes later, it had a total of 48 gallons. So I'll put 2 minutes, 48. 5 minutes, it held 61.5 gallons. What was the rate of change in the number of n of gallons of water from 2 minutes to 5 minutes? So we're going from 2 minutes to 5 minutes. We'll find the rate of change. So we know that at 2 minutes, it had 48 gallons. And at 5 minutes, it had 61.5 gallons. We find a rate of change. Well, rate of change is another fancy way of saying slope. So what is the slope between those 2 points? So slope is y2 minus y1. So it's going to be 61.5 minus 48 over 5 minus 2. That gets us on top 13.5 divided by 3, which is going to give us 4.5. So what is the average rate of change? It is 4.5. And what are our units? Well, the units on top, those were both gallons. So it's going to be gallons divided by, or per, those are minutes, so gallons per minute. Okay. Next question is, how many gallons of water were in the tub at the time the cold water was turned on? Well, I'm going to try to think about this kind of like a line. So there's some amount that we had at the start. 2 minutes in, we had 48. And then 5 minutes in, we had 61.5. The question is, well, where do we start? Well, because this is going to look like a line, I mean, it's in the linear function section after all, I'm going to set this up as y equals our slope, which we just got an approximation, which is 4.5. I'll say x, though we're going to have to switch out the variables in a little bit because it wants us, the next part will want it in terms of n and t, plus b, where b is this y-intercept, is our starting amount. So we're looking for b. Well, we have 3 unknowns here. What can we do? It's a great question. We can use the fact that we know some spots on this line. We know at 2, it's going to be at 48. So that means that I'll have a y value at 48 whenever my x value is 2. And now I only have 1 unknown. So I can go and solve. 48 equals 9 plus b. So that means that 39 is equal to b. So how many gallons of water in the tub when it's turned on? 39 gallons. And now for the last part, it wants a linear function, aka equation of a line, for the number of gallons. So it's going to be, instead of y, we're going to use number of gallons, so n equals, and then it's the number of gallons at time t minutes after turning the water. So our slope was 4.5. Instead of x, we're going to say t, and our starting value was 39 gallons. And there we go. That's it for that one. Okay, so now for number 9, we have when a small business sold 60 bars of soap, they earned $0 in profit. So 60 bars of soap gives us 0 profit. And 95 bars gives us $280 in profit. So we need to write a linear function for the profit earned in dollars by selling n bars of soap since starting the business. Be sure to use variables given. So we're trying to figure out and equate a linear function, so we align for this. Well, a line is going to be in the form y equals mx plus b, or in our case, it's going to be p equals m times n plus b, because p is our y variable, n is our x variable, because our profit is going to depend on the number of bars we sell. So to find our slope, we need 2 points. Well, we have the point that when we sold 60 bars of soap, we had 0 profit, and when we sold 95 bars, we had 280 in profit. So we can find the slope using those 2 points. So slope is y2 minus y1 over x2 minus x1, which is 280 over 35, which is 8. So we our slope in this case is going to be 8. I guess in this case, dollars per bar is how much we make. So that means our equation is going to be P equals 8 times the number of bars you sell plus B. And we need to figure out what B is. So the question is, how do we figure that out? Well, we can use some of the information we have. Our profit, which is P, is $0 when we sell 60 bars of soap. So 8 times 60 is 480. And we can finish solving this for B, so that's minus 480 equals B. So our equation is going to be P equals 8 times N minus 480. So how much profit do they earn for each bar sold? That's what our slope is, right? For every one increase in your independent variable, in this case N, so every time we sell one more bar, our profit increases by 8. So the amount your y increases for each one change in your x. So in this case, the amount our profit increases for each bar we sell, which is $8. How much did it cost to start the business? Well, that is saying if we don't sell any bars, how much did we have to spend no matter what? So if I plug n equals 0 into that, you get minus 480. So that means $480 took to start the business, because if I don't sell anything, my profit will be negative $480, which means I've already spent $480 on this. Finally, find the equation of the secant line that passes through f of x equals negative 1/2 times x minus 2 squared plus 1 at x equals 2 and x equals 4. So we're trying to find the slope of the, find the equation of the secant line, right? So we find the equation of this line. And what do we know? We know that there's at two different spots, x equals 2, x equals 4, it'll intersect this. So, in other words, we can find the y values for these 2 points on our line by plugging them into this equation. So, I'll do -1/2, 2 minus 2 squared plus 1. Well, 2 minus 2 is 0, so -1/2 times 0 plus 1 is just going to be 1. I can plug in 4 as well. It's -1/2. 4 minus 2 squared plus 1. 4 minus 2 is 2. 2 squared is 4, so -1/2 times 4 plus 1. -1/2 times 4 is going to be 1/2 of 4 is 2. Make that negative, so -2 plus 1 is going to equal -1. So we have the point 2, 1 and 4, -1. So to find the equation of the line that passes through each of these points, we need to find our slope. So our slope is going to be y2 minus y1. I'm calling this one y2 and x2, and this is x1, y1, over x2 minus x1. So -1 is going to be -2. 4 minus 2 is going to be 2. -2 over 2 is going to be -1. So that is our slope. So going back to the equation of a line, equation of a line is y equals mx plus b. M is our slope. We just found that. So that means that we know it's going to be y equals -x plus b. Now to find b, we can just use either of our 2 points that we found. So I'll use this one. So that means that -1 is going to equal -4 plus a b value. Well, I can add the 4 over, get 3 equals b. So that means that the equation of the secant line is going to be y equals -x, because -1 times x is the same thing as just -x, plus 3. And then we're done.